Hello, this presentation is the second practice question in the inclined plane topic. If you haven't yet watched the first part in this series, it is highly recommended to do it now before you watch this second part, because in the first part I describe all the fundamental methods necessary to solve the inclined plane questions, and I will repeat some stuff now, but definitely not everything, so it is really a good idea to watch the first presentation first. This one is highly based on the same basically the same principle, and even the question starts like this: the same object has been placed somewhere in the middle of the ramp. So let me switch this presentation to the pen mode, and let's make some kind of a drawing. So again, we have an inclined plane. This is the ground of this plane and inclination in the inclination angle. The same object has been placed somewhere in the middle of the ramp, so it would be somewhere here. Find its height above the base of the ramp, so it would be this height here. Okay, this is height. Let's call it h as it's shown here. Find the height above the base of the ramp. If you know the time, which is 1 second, it takes to hit the ground starting from a standstill. It's the same ramp, so we have the same inclination, alpha equals 30 degrees, the same friction, 0.1, but you can notice that indeed this is a different starting position, because in the previous question time was 2 seconds, and here is just 1 second. As I mentioned, and I will repeat once again, it's very important that you watch the first part before watching the second part, because what I'm going to do now is, with just a single click, to repeat something that I call a no-brainer part of the solution of inclined plane exercises. So we have the sliding force, which is responsible for moving things down the slope, normal force, which is responsible for depressing things towards the plane, and friction, which prevents inverse motion. And I will not repeat the way in which we can find these formulas. It's explained in detail in the first part of this presentation, but I will tell you that nearly every exercise in inclined planes will start the same way. We'll start with the same calculation of sliding force, normal force, friction, so feel absolutely free just to rewrite these three formulas when you start your exercise in the in-class test. I will also provide here some data for future calculations. So gravitational acceleration g is equal to 10 meters per second squared, and please remember that the real value is of course 9.81, but we round it up. Sine of 30 degrees is 0.5, cosine of 30 degrees is 0.87, and that's basically what we need to know in order to start this little exercise. A very important thing is to understand that we have the sliding force, which moves the object down, and this sliding force is given as mg sine alpha, and we also have the friction force, which is a so-called pseudo force, because it's not a real force, but it's acting upwards, like if it tried to prevent the movement down, and this friction force is here. The next inevitable step is to find the net force. Okay, the net force F, which is equal to the sliding force. This is the observable force that moves the object down, minus friction, because this is this additional force which tries to prevent the sliding motion. And both forces are provided by the formulas that I underlined already here for your comfort. So it's mg sine alpha minus fmg cosine alpha, and exactly as in the previous question, previous exercise, previous part of this video series, we will extract mg as the common component here and here in front of the bracket, and inside the bracket we get sine alpha minus f cosine alpha. The next step is to find the acceleration A according to the second law of motion, or Newton's law. It's the net force divided by the mass of our object. But this is the formula for force. You can see that it starts with mg divided by m divided by m is always 1, it cancels itself, so our g is just, a is just g times sine alpha minus f cosine alpha. What I have just done here has actually quite an interesting physical deeper sense. This deeper sense is that the movement of the object placed on this inclined plane, the acceleration of this movement, so therefore velocities, times, whatever, doesn't depend on the mass of the object. So a more massive object will move with the same speed as a lighter object, at least as long as we ignore the aerodynamic drag. And now it is important to notice that the distance traveled by my object depends on, I will change the color, it's this line here, okay, and it can be found from a triangle like this one. I will call this value here x, okay. So the next step, I will switch back to red. I have no idea why I'm writing this in red. This was just a default color in PowerPoint. So this distance traveled by our object, distance x, in the situation in which we already know acceleration and we know time, can be very easily found from this formula, which you should find in your formula sheets, or you should just remember. That's the distance in accelerated motion in the case in which the initial velocity was 0. Okay, it's simply at squared over 2. To do this calculation, I will do it now. I will do all the calculations to find the value of alpha. So let's say alpha equals g is 10 times sine alpha is 0.5 minus f is here is 0.1 multiplied by cosine alpha is 0.87, and it happens that exactly the same calculation was presented in the previous presentation. So instead of doing these calculations, I will just provide you with the value of acceleration. It's 4.13 meters per second square. Now I have everything that I need in order to find the distance traveled. So this thing here, distance traveled by my object, so it is a 4.13 times time is 1 second, so it's times 1 to the power 2 divided by 2. 1 to the power 2, 1 squared is of course 1, so it's 4.13 divided by 2, and this is exactly 2.065 meter. This is not yet the final result of this exercise, because we are asked, where is it, find its height. Okay, so basically this is something like find h, when you know x is 2.065, and you know alpha. So again, simple SOHCAHTOA, all right. In this case, we have a hypotenuse and an opposite edge, so the sine function, sine alpha equals the opposite, which is h, over the hypotenuse, which is x. From this, we just need to find the h, the height, which is, I need to multiply both sides of this equation by x, so it's x sine alpha, and this is very simple to calculate, because x is 2, this is x by the way, okay, so this is x is 2.065 multiplied by sine alpha is 0.5, and the result is, I will write it here, h equals 1.0325 meters. That's the solution of our second inclined plane practice question. Thank you very much, and I invite you to the third practice question.